So now that we've talked about soluble versus insoluble compounds, let's look at an example of how this applies in practice. I think that's the best way to explain how we can think about precipitation reactions. So let's imagine we have a beaker where we've added lead nitrate to one, an aqueous solution, and sodium iodide to another beaker. And let's mix these together. So we'll pour one of these into the other. Now, let's first start with looking at our solubility rules. Are these compounds that we're starting with soluble? So we'll first look at the lead nitrate. So we don't have rules specifically about lead, so let's look at the nitrate. And if we go back to our list, I encourage you to look on Moodle. There'll be posted that list of the solubility rules that I showed in the last video. But nitrate is one of these that is always soluble. So any compound that forms with nitrate is going to be soluble in water. So this is soluble, so this will be a colorless solution. Sodium iodide is another one where sodium is one of the alkali metals, so it's in the first column of the periodic table. And this is another one where anything in that first column, any ionic compounds that form with them, these are always soluble as well. So we're starting with two soluble compounds. So if we sort of draw, what's going on inside of them, we'll have lead 2+ ions and nitrate ions floating around in solution, and sodium ions and iodide ions floating around in solution, separate from each other, no solid present. So these would look like clear liquids. What happens when we mix these together? And that's the question here. So let's think about lead nitrate. We'll go ahead and write this out as a chemical equation. Got to remember the 3 there. And we're going to need 2 of those to balance the charges. And sodium iodide. And the question is, what will happen when we mix these together? Now this is an example of what we call a double displacement reaction. What that means is we're going to swap the positive and negative ions. So when we start, lead is associated with nitrate, sodium is associated with iodide, but we're going to swap positions. So we're going to say, well, let's take, and this is where I can use colors to my advantage, let's take lead, and instead of combining it with nitrate, let's see what happens if we combine it with iodide. And then let's use green. And then we can take our sodium and combine it with the nitrate and see what happens when those combine with each other. And what we're looking at here is mostly we're trying to see, are these soluble or insoluble when we swap their partners. So our 2 partners that we'll have after we swap are going to be lead with iodine, and to balance that we'll need 2 iodides, and sodium with nitrate. Those are both, there's a +1 and a -1 ion, so we're good there. Well, we can start with the bottom one. All nitrates we said are soluble, and all compounds that go with the alkali metals are also soluble. So this is going to form a soluble compound. So these ions are not going to do anything. They're going to stay soluble. They started soluble, they're going to stay soluble. On the other hand, our lead iodide, if we look at our solubility rules, again, we don't have anything specifically for lead, but for iodide, almost all iodides are soluble, except lead is one of our exceptions. And if we go there, we'll see that this compound is insoluble. So what's going to happen when we mix these together is that the lead and iodide ions will find each other, they'll combine and form a solid, and that will precipitate and fall out of the solution. What does this look like in practice? We're going to continue with this reaction in just a second, but I just want to show a picture. This is a figure from your textbook just to show what this looks like. So here we have our lead nitrate here in the bottom and our sodium iodide here, and we can see they both start as colorless liquids, but when we pour them together we see this yellow stuff form, and this is the lead iodide. It happens to be a yellow color. One fun thing about precipitation reactions, sometimes they're colored, and so you get these nice colored solutions that seem to appear out of nowhere, but they're not out of nowhere. They're from the ions that are present in the solution combining with each other. So the lead and iodide are this yellow compound, and so that lead iodide will, the lead 2 iodide to be more specific, will stick around in solution and slowly fall down to the bottom of the solution because the solid's heavier than water. And you can actually centrifuge this, cause all the solid to go down to the bottom, pour off the liquid on the top, and you get lead iodide left behind. You get the chance to do this in your labs. So that's what it looks like in practice. A precipitation reaction will often look like this. Now let's go ahead and come back to our equation here, and we can analyze this in terms of thinking of the we have the basic idea of the ionic, not ionic, but the molecular equation here. We need to balance it, of course, so we'll need 2 lead iodides or sodium iodides and 2 sodium nitrates to balance this. And I should write this with proper. Now that we know one's soluble, one's insoluble, we can write these with the proper phases. So our insoluble compounds will always be solid, whereas our soluble ones we write as aqueous because they dissolve. So this is our molecular equation, but let's write the total ionic equation, and then we'll do the net ionic equation. So just like we did for our acid-base reactions. So our total ionic equation, everything was soluble on the left-hand side of the equation, so we can write them as their individual ions. And we're going to still need these 2 nitrates to balance our charges here. And then same thing with our sodium and iodide ions. And then our products are going to be our lead iodide. That'll be a solid. And then our sodium nitrate is going to be present still as ions because it's a soluble compound. Okay, so we've got our total ionic equation here. It's balanced. It was already balanced in the previous version. We just kept that balancing here. And now we can identify our spectator ions. Let's use pink. So we see here that our sodium and our nitrate are the same on both sides of the equation. So these are our spectator ions, which means that we can eliminate those from the reaction equation when we write the net ionic equation. Because they just stay soluble the whole time, they are just sitting around and don't participate in the reaction. So our net ionic equation will be everything that's left, which is our lead ions plus our 2 iodide ions reacting to form our lead iodide solid. So that's an example of how we can look at a precipitation reaction. And this is an example of how we can know the reaction is going to happen because this insoluble compound is forming. So with precipitation reactions, it's all about soluble versus insoluble compounds. We will usually start with things that are soluble, though not always. There are exceptions to that. And we'll look for something insoluble to form. Now, one thing that can happen is that both of your products, in this case we had an insoluble and a soluble product, one thing that can happen is both your products are soluble. And in that case, there's no actual reaction that occurs. If you went through the process of finding the net ionic equation, everything would be a spectator ion, and there would be no reaction that occurs. So essentially, you'd mix it together, and everything would just stay the same. There'd be no solid that would form. So that is a possibility that can happen. But if we're looking for a precipitation reaction, we need to see that an insoluble compound forms.